and I'm a sophomore at Tennessee Tech. I'm currently taking a Design of Algorithms course, and my fellow group members and I, which my fellow group members are Mackenzie Kajeski and Jenny Thomas, were tasked to create a project revolving around these four searching algorithms: breadth first search, depth first search, bidirectional search, and A*. We decided to name our project Ticket to Tech, and I will explain what our project entails of. So basically, we looked around campus and we realized that there were a bunch of buildings and a lot of students. We started thinking about our day-to-day schedules, and we realized that with so many students, sometimes it's hard to get to class on time. And we decided we wanted our searching algorithms to revolve around finding a great path at Tennessee Tech. And so the purpose of our project was to find the best searching algorithm to search for the best path at Tennessee Tech. And basically, our name, Ticket to Tech, came from this board game, as seen on the next slide, Ticket to Ride. Ticket to Ride was a classic in our households. This is the board of Ticket to Ride. As seen here on my pointer, Seattle's the location, marked by all these trains, and the goal was to basically lay down trains of these colors to mark a path, or similarly to the graph, a vertex, a path in between vertex. So an example would be Seattle to Duluth. And the goal of this game was to complete all these path routes to gain points. And whoever had the most points when the game concluded won. So this inspired our small graph for our project, which included 4 vertices: AIEB's the new engineering building, BRU's Bruner, LIB's library, and RUC is the Roden University Center. We created such a small graph because we didn't know how much time we would have as college students. Eventually, this evolved to a medium graph where we added 4 new vertices. And shockingly, we had enough time to make a large graph with 8 additional vertices. We made these graphs to be real-world application input into these 4 algorithms, searching algorithms: depth first search, breadth first search, bidirectional search, and A*, as I mentioned earlier. In our code, we both did Python and C++. We measured the amount of time it took for our code to find the optimal path from different points that the user entered. To find out more about our presentation, please view our report and look at the results and interpretation. This is just an introduction to explain what our project's about. So thank you for viewing and watching. Have a great day.